So we've looked at various methods of doing of finding volumes by disc washer or shell method. We also looked at slices, which was quite preliminary. But it could get confusing whether to use the disc washer method or the shell method. Okay, and here you have a summary. Okay, if you'll take a look here on the left-hand side, you'll see integrations with respect to x. And this occurs if you're using the washer method. You would rotate about the x-axis to do an integral over x. On the other hand, with the shell method, you get the height of the shell with the f and g of x, but the shell circumference is 2 pi x. So you'd actually rotate about the y-axis if you're integrating with respect to x. Okay, and here you'll see two images that summarize for you what kind of volumes you'll be getting using the disc and washer method versus the shell method. What happens if we do integrations with respect to y instead? Well, with integrations with respect to y, you can see the disc washer method will give us a volume that we get from rotating about the y-axis. Okay, and in there you'll have an inner and outer radius that you see there, the outer radius py, the inner radius qy. On the other hand, rotating about the x-axis with the shell method gives you an integration with respect to y. Okay, so pay attention to that. It can be a little bit confusing, but it's because you're taking different shells. As you could see over there, the height of a shell is now py minus qy, and the circumference of that shell is 2 pi y. Okay, and so that's just a quick summary of the different volumes that you could get using the shell and washer method.